Good morning, students. Today we are going to discuss about alternating current, right? That is AC, alternating current, right? Students, in last class we discussed transformer and losses in transformer, right? Okay. So today we are going to discuss about alternating current. Okay, right. Small introduction for alternating current. See this, William Stanley and yes, that designed one of the first practical devices to transfer AC power supply and AC power efficiently between isolated circuits, right? And the power system, AC power system, used to develop rapidly after 1886 and included contributions by Nikola Tesla and Carl S. Wilhelm S. Siemens. Okay, so this is that picture of William Stanley and this Nikola Tesla and S. Wilhelm Siemens. Okay. So Williams only designed one of the first practical devices to transfer AC power supply efficiently between isolated circuit, right? Okay, students, right. And what is alternating current? First, what is alternating current? See the first point, alternating current electricity is the type of electricity commonly used in homes and businesses throughout the world. So it is electricity is used in homes and businesses, right? And AC electricity is created by an AC electric generator which determines the frequency. So the AC current created by AC electric generator. Okay, students? Right, okay. Next, last point. An AC waveform can be sinusoidal, square, and sawtooth shaped. So it is shape is nothing but sinusoidal. What is sinusoidal? Sinusoidal is nothing but sine wave function. Which wave function? Sine wave function. So that is that sinusoidal. Yes, that is sine waves. Okay, and square waves. Okay, right. And some AC waveforms are irregular or complicated. Some waveforms are irregular in shapes. Okay, sometimes that triangle waves like that. Waveform of alternating current. Which form? Waveform. Okay, students, right. Now come to the difference between the AC and DC. The alternating current flows first in one direction and then in the other direction. See, we are taking that battery. The battery delivers the current, DC current, direct current, almost 0.5 voltage. So the battery delivers the direct current. But see this alternative current. The alternative current flows in one direction and then in opposite direction or other direction. Okay, right. First, advantages of AC. The single greatest advantage of alternating current is that AC current can be transformed and DC current cannot be transformed. So we can transfer the current, AC current. Okay, that's why AC current can be transformed and DC current cannot be transformed, and it can be controlled by wide range of components. This AC current is controlled by wide range of components. Examples: resistors, capacitors, and inductors. Right? Resistors, capacitors, inductors. Okay, right. And this AC current allows high voltage electrical power to be distributed with smaller wires and lower amperage, that is lower ampere. Okay, this is the advantages of AC than DC, right? Okay, this is a small circuit for your understanding purpose. So this is the DC current and this is that AC current. See, this is AC generator and this is switch and this battery, just a small circuit. So this is that so electron flow. These lines are indicate the electron flow. Okay, right, and this is the direction of that. This is DC and this is switch and this is the AC, right? But come to this one. See, AC only connected. See this AC only connected like this. Okay, this is the electron flow. But see here the AC is not connected, the only DC is connected. That's why direct current. That's why direct current, because the electron flow is opposite to the positive, right? Okay. RMS values. What is RMS? Root mean square values. Okay, I will tell you clearly later, but you should know this points. Okay, since voltage and current are always changing, we need some way of averaging out their effect, and we use RMS values in this AC current to measure the AC current. RMS value is nothing but root mean square value to measure the AC current in the circuit. The RMS values are the DC values which gives the same average power output. It gives that same output power. Okay, students, right? Yes, other points is of alternating current. The AC stands for alternating current. We know that the main supplies AC, and AC current flows backwards and forwards in a circuit. The symbol of AC power supply should be like this. So this is that symbol of AC power supply in a circuit. The current in AC circuit flows one way and other way, that is in another circuits also. Okay, so this is the N and this is that way. This is the ampere, this is ammeter, and to connected AC circuit. Okay, right. Alternating current. If the alternating current, that movement of electric charge periodically reverse directions. In direct current, the flow of charges only in one direction. That is the main difference between the AC current and the DC current. The alternating current moves or movement of electric charge periodically reverses directions, but the DC current flows only in one directions. And the AC electricity is widely used because some reasons. The reasons are here. It is easily produced by generators. It is easily produced by generators, and the maximum voltage can be changed easily using a transformer. So we can change the maximum voltage to lower voltage, okay, and it can be controlled by wide range of components. The AC current can be controlled by wide range of components, and it has a regular frequency with which is useful for timing. So it has a regular frequency. Okay, students, right. So again, direct and alternating current, AC current and the DC current. Yes, because you should know the difference between the DC current and AC current, then only you'll understand the remaining is topics. Okay, DC current, a current that always flows in one direction only is called a direct current. We know that, and the current we get from a battery is a direct current. I already said no. If I am taking one battery, the battery deliver the DC current almost 0.5 voltage, right? But if you go to home, yes, so power supply is AC current, that is alternative current, right? Okay, now come to this one. The alternating current that has reverse its direction, periodically it is called as alternating current. But see this, the most power stations in our country produce alternating current. So all the power stations in our country producing alternating current, because alternating current changes direction every in 1 by 100 second, every 1 by 100 second, and that is frequency is 50 hertz. So if hertz is the unit of frequency, if you go to that meter box and there is that a number mentioned below that, the voltage and the frequency mentioned in your is home power supply meter box. So that is that frequency of AC current, that is almost constant 50 hertz. So frequency of alternating current is 50 hertz, right? Okay, and one advantages of AC over DC is it can be transmitted over long distances without much loss of energy. That's why we are generating the electricity, and that electricity is transformed to long distance and transmitted over long distance, and we are yes, with the help of cables, high voltage cables through towers. Okay, so we are in Tamil Nadu, and we are generating yes electricity, and that electricity transmitted to the neighboring yes states like Kerala, Karnataka, Andhra. Okay, with the help of high grid cables. Okay, so without yes heavy loss of energy. Yes, the loss will be takes place, but it's not that much. The loss takes place only few amount of values. Okay, that's why the AC is transmitted over long distance without much loss of energy. The energy loss is nothing but heat loss. So that is basic thing. Okay, now see this, the graphical representation of the direct current and the current and the time, it is always constant direct current. But if you go to this side, alternating current, see the peak values are like this. So every 0.1 second it changes the direction, right? So this is the current, and here time. See, every 0.1 second they change their phases, right? Change the phases. So every second changes the phase. Okay, students, right? And AC in capacitors. See, in AC circuit the current can continue to flow as the plates becomes alternatively charged positively and negatively. As the phase plates becomes alternatively charged, one is positive, another one is negative. For both DC circuit, AC circuit, the voltage across the resistor related to the current, that is according to Ohm's law, V is equal to IR. But a similar relationship exists for a capacitor, right? Exists for a capacitor. Okay, and according to, if I'm taking that is capacitor, the voltage which is equal to I into XC. I is the current, XC is that capacitance, right? Capacitance. Okay, V is the voltage. And reactance is the measure of how the capacitor can limit alternating current, and it is similar to a resistance but differs in that it is independent on the frequency of AC power supply. If I'm taking that this one, sorry, XC, see, V is equal to IR formation, VC is equal to I is the current, XC is the reactance, capacitance reactance. Which one? Capacitance reactions. This capacitant reactions depends on capacitor size. So that capacitor XC, which is equal to 1 by 2 pi FC. F is the frequency and C is the capacitance. So the reactance, capacitive reactance XC is equal to 1 divided by 2 pi FC. Okay, students. And now if I am taking that inductor is nothing but coil. So if I am taking coil, given the AC current flow to the coil, what will happen? So in AC circuit, the current is always changing, so that the inductor is always producing an opposing voltage. So it's always limiting the amount of current that can flow. For both AC and DC circuits, the voltage across the resistor related to the Ohm's law is equal to IR. But if I am taking that inductor case, the voltage in inductor VL, which is equal to I into XL. XL is nothing but inductive reactance. XL is nothing but inductive reactance. See, this is the generator to produce the which one? To produce alternating current. Which current? Alternating current. The same one. See, alternating current, it has timing. See that when the voltage applied an AC source is an harmonic with the period, that means sinusoidal. It is nothing but wave function. So AC signal is a which wave function? Sine wave function. That's why called as sinusoidal. Okay, students, right? And then AC cycle, and if you are taking that, so this is the one cycle. See this, start from here into up to this. So up to this one cycle, right? So when this cycle, the complete revolutions of AC generator, one cycle of AC generator is made up of two alternations. One is positive alternation, another one is negative alternation. Okay, positive and negative alternation. And the frequency, the number of cycles in a second is nothing but their AC frequency, that is always constant. And if you go to that, the unit of frequency is Hertz. But if you go to the household current, 60 Hertz, but in his household current frequency is 50 hertz in India, and here 60 hertz, but most we are there using 50 hertz, that is 50 cycles per second. 50 cycles per second. Okay, and this is that is degree of rotation for phase changing, that is 0, 90, 180, 270 and 360, like this. So the alternatively the current changes now, so that's why degree of rotations. And degree of rotations also, see that based on this one it will be changes like this, alternative current. And come to this one, if you are taking the cycle, it has amplitude and peak, peak to peak, it has period and it has frequency, right? You should know the terms. If you are taking the one AC function, it has these contents. One is amplitude, and this amplitude, it is the value of the wave from 0 to maximum, right? And the next one is peak. The maximum value of the amplitude is peak, and peak to peak, the value measured from one peak to other peak, that is peak to peak values, right? And the period is time period. The time of one complete sine wave, it will take some time to complete one sine wave, no? That is the time period. The next one is frequency. The frequency is nothing but number of cycles per second. Number of cycles per second. That is F is equal to 1 by T. Reciprocal of its time period is nothing but frequency of AC wave. And now that effective or RMS values. Okay. You should know the value. I'll tell you later exactly what is RMS and how to find out the value for this one. Okay. Okay, see the one, effective value of AC is the most AC that produces the same heating effect as equal to amount of DC, but the effective value is determined by the mathematical progresses called root mean square value or root mean square method. So from the method, the value for is RMS value 0.707. Okay, so please underline the value. I'll tell you is how to calculate this value later. Okay students, right? So this is the book content, alternating current. And alternating current is the voltage which changes polarity at regular intervals of time, and the direction of the resulting alternating current also changes accordingly. So see, this is the book definition for AC, alternating current. Okay students, so this is the AC is power supply is connected to one resistor, positive negative. If I am change the positive negative, the direction of current will be changes. See, if I am taking connecting positive, the direction of current like this. If I change that input alternating current, the current direction will be changes. Okay, so this is the small resistors connector. Okay students, right? And I said now sinusoidal function. So if the waveform of alternating voltage is a sine wave, then it is known as sinusoidal alternating S voltage, which it gives by the relation V is equal to Vm sine omega t, right? So where V is the instantaneous value of alternating voltage. The sinusoidal function like this, V is equal to Vm sine omega t, where V is the instantaneous value of alternating voltage. Vm is the maximum value, that is maximum amplitude, and omega is the angular frequency of the alternating voltage. So this is the formula. Yes, alternating voltage formula Vm sin omega t, right? Sinusoidal function. If the waveform of alternating voltage is a sine wave, because I already said AC current wave function is a sine wave. So sine wave function is known as sinusoidal alternating function, which is represented by V is equal to Vm sin omega t. Okay, students, right? Okay. See, this is that alternating current like this. Sinusoidal. This is positive cycle and this is the negative cycle. So this is that alternating voltage and this is that alternating current. So omega t is that angular velocity. Okay, sinusoidal voltage and the sinusoidal current. Sinusoidal AC voltage and sinusoidal AC current. Okay, right. You see the note. Interestingly, sine waves are very common in nature. The periodic motions like waves in water, swinging of pendulum are associated with sine wave. And thus sine wave seems to be a nature standard. So we'll go to the refer the 11th book, unit 11. Okay, right. Students, today class is over. So in this class we discussed what is AC, how to measure the AC, and what is DC, what is the difference between AC and DC, right? And what is the wave function of AC. Okay, so students, so these are the basic for AC. Okay, students, in next class I'll give you how to calculate the RMS value and capacitive reactance, inductive reactance, and that and all. Okay, students, right? Okay, right. So see you next video. Okay, students, thank you.